Okay, gang, this is from section 3.2. We need to find the slope at the indicated point. Let me just make sure I read that right. Slope at the indicated point. Okay, we're now going to use a quicker derivative rule. So remember, when you use a power rule, you do not do it from the denominator. So you need to bring this up. So it's 8x to the negative 2, right? You got to bring it up because you do not do the power rule from the denominator. All right, so now take the derivative. So I bring the exponent down in front, times it by the 8. Subtract 1 from the exponent. And if you want, I can rewrite it down. Okay, so that is the derivative. Now you're going to evaluate the derivative at the coordinate. At this point, our derivatives are just strictly in terms of x. Later on, they will be in terms of... Sorry, let me watch how I say that, because the derivative could be in terms of theta. What I'm trying to say is that right now, the derivative will just have one variable versus like 2. All right, so now I plug in, it just wants the x value. So now I do f prime of 2, which is the x value is negative 16 over 2 cubed, or negative 16 over 8, which reduces to negative 2. All right, so that is the slope of at this point on this function. And they're not asking for the tangent line, but if they were, you would then just find b. All right, same idea here, same concept. We need to find the slope at this coordinate. During lecture, I mentioned the derivatives of the 6 trig functions. Please memorize those. You want to sort of have those handy in your brain. Now the variable here is theta. So the derivative of sine is cosine. And the derivative of theta is 1, but there's a negative in front, so it's negative 1. Now, some people get a little confused because it's a theta, but they won't. I notice sometimes they don't get confused when it's an x. So sometimes it's just a variable looks weird because you guys know the derivative of x is 1. It's just that they're using theta instead of x. All right, so this is the derivative here. We're now going to calculate the slope. So, I'm writing xy, but this is not an xy function. This is a theta f theta function. All right, so now I'm going to plug in theta, which is 0. So f prime of 0 equals to 4 cosine 0 minus 1. Whenever you're on a quadrantal angle, you need to be on the unit circle. So on the unit circle, the cosine at 0 is 1. So this is 4 times 1 minus 1, or 4 minus 1, which is 3. So the derivative at this coordinate on this graph, the slope is 3. All right, that's it, gang, for this. Hope that helped.